guns. We are live. Time to get to work and talk this jive. Okay, so dilutions. Dilution is when you change a solution by adding water to it. Okay? So think about what changes and what stays the same when you add water to a solution. Okay? So what's in a solution? For a solution, you have your solute and you have your solvent. Your solute is staying the same, even as the solvent changes. So the moles of your solute is not changing. Okay, that's staying perfectly fixed. But the volume of your solution is changing because you're adding more water to it. And so is the concentration of your solution. If you increase the volume, the concentration has to go down because you have more solution. So here's the thing. The concentration and volume of your solution before you start doing anything to it is going to be the moles. Molarity times volume gets you moles. But the same is true for when you're done. The molarity times the volume is still equal to moles, and the moles hasn't changed. So the initial molarity times volume is equal to the final molarity times volume because they're both equal to the number of moles of solute. The moles of solute stays the same, so these two products stay the same. So you can represent this as M1V1 equals M2V2. The initial product of the molarity and volume is equal to the final product of the molarity and volume. Or if you're some kind of freak, MAVA times MBVB. But who uses letters? I mean, God, gross. So, how much water do you add to 12.5 milliliters of 1.250 molar hydrochloric acid to make a 0.7500 molar solution? All right, so here's how we do these problems. These are fairly straightforward. Okay. So, M1V1 makes M2V2. So for this problem, we know our initial concentration and our final concentration. Okay. We're starting at 1.250 molar. And we're ending at 0.7500 molar. We also know our initial volume, 12.500 milliliters. So what is our final volume? Okay. Now the great thing about these problems is that you don't have to convert back to liters, okay? Because the units will all work out no matter what you do. So we know our initial and final concentration, we know our initial volume, we're looking for our final volume. So final volume is equal to M1V1 over M2. So that's why we don't have to worry about converting our units. Molarity divided by molarity cancels out, leaving you with units of milliliters. So it'll work out just fine. So volume 2 is equal to 1.250 molar times 12.500 milliliters divided by 0.7500 molar. So our units of molarity cancel out, and it's going to leave us with units of milliliters. So we plug that into our handy-dandy calculator. 1.25 times 0.125 divided by 0.75 means that our final volume is 0.2083 milliliters. That cannot be right. (1.25) times 12.5 divided by 0.75. Okay, I screwed up somewhere. I think I must have automatically converted this to liters in my head. That's the only explanation. No, because I was only off by 2. I have no idea. I must have done 0.125 there, I guess. I don't know. Anyway, the point is our final volume is going to be 20.83 milliliters. Now here's the thing. That is what we are diluting to, but That's not how much water we're going to add to our solution, because we're starting with 12.5 mils. And I asked, how much water do you add? Okay. Yeah, this is kind of me being a punctilious wang, but also I want to highlight that when you do a dilution, you're adding a certain amount of water to an already existing volume of solution. So in order to dilute this appropriately, you're going to have to add a volume of solution to get where you want to go. We're starting with 12.5 milliliters. We want to end with 20.83 milliliters, which means you're only going to add 8.33 mils. So that is, I think, a valuable distinction. You are eventually going to end up doing some kind of lab work with this stuff. So you need to remember, when you do a dilution, you're adding a certain amount of fluid, a certain amount of solvent, to an already existing volume to get to a different volume. This is not the amount of liquid you add. This is the amount of liquid you end up with. This is how much you add. Okay? That's a distinction that I want you to keep in mind when you finally get in the lab. So let's move on to the next problem. What is the concentration of a solution of sulfuric acid if you dilute 10 mils of a 0.5 molar solution to 15 mils? Okay, so now we have our initial volume and our final volume, and we have our initial concentration. I'm asking, what is the final concentration? It's the final concentration. Okay, so M1V1 equals M2V2. We know our initial concentration, our initial volume, and our final volume. We're looking for our final concentration. So M1V1 over V2. And again, you don't have to convert to liters because milliliter divided by milliliter will cancel out just fine. So M1 was 0.5000 molar. V1 was 10.000 mils. V2 is 15.000 mils. So you see, that's one of the great things about these dilution concentrations, or dilution math problems. You don't have to convert to liters the way you do for straight up molarity to moles sorts of things. All right, you do in other cases. So it doesn't hurt to convert to liters, but you have to remember to do it to everything. All right, so in any event, we break out our calculator. 0.5 times 10 divided by 15. It's going to give us a final concentration of 0.3333 molar. Okay. So our volume went up by 3/2. Our concentration went down by 2/3. All right, next up. What? Go away, stupid. What volume of 1.125 molar sodium nitrate should you dilute to 150 mils if you want a 0.8750 molar solution? So this is kind of a weird way of asking it, but you have a stock solution, a big jug of sodium nitrate at 1.125 molar. For some reason, you're doing lab work, you need 150 mils of a lower concentration solution. So you're going to measure out some volume of your sodium nitrate, and you're going to dilute it to 150 mils. What volume are you going to start with? Breaking out the paper. All right, so M1V1 equals M2V2. In this case, we know our initial concentration, we know what concentration we're shooting for, and we know how much of that we want. So what is our initial volume? We rearrange. V1 is equal to M2V2 over M1. So we're going to end at 0.8750 molar. We want 150 mils of that solution. And we're starting with a 1.125 molar solution. Once again, we don't need to worry too much about our units because molarity cancels out, leaving us with mils. Okay. So, calculator time, 0.875 times 150 divided by 1.125. And we're going to start with 116.7 mils. So we're not going to add too much. We're just going to add 33.3 mils to this in order to dilute from 1.125 to 0.875. All right, so dilution problems are relatively simple just because they pretty much always follow this formula. For the simple reason that it's all you're doing is adding water to stuff. Okay. So now let's look at something else. There's a thing out there called homeopathy. Homeopathy is a branch of pseudoscience that calls itself medicine and absolutely is not medicine. One of the rules of homeopathy is that you treat diseases by giving people, hold on a second, I'm going to need this real quick. You give them medicine that causes the same symptoms as the disease. So if the disease causes vomiting, you give them something to make them vomit. If it gives them a fever, you give them a medicine that will give them a fever. Now, the thing is, homeopaths, although they're quacks who sell stuff that isn't medicine, they're not, terrible people. They're not monsters. They don't want people to die. So they know that giving you a poison is bad. So instead, they dilute the hell out of it. How much do they dilute it? Well, they have a couple of different ways of doing that. They can dilute it by a factor of 10. They can also dilute it by a factor of 100. And then they will repeat those dilutions many times. So, here we have homeopathy based in nicotine. And yeah, nicotine is kind of a poison. Yes, it's an addictive drug, but the plant's intended as a pesticide. So I'm not sure what a homeopath would use it for, but it makes sense that they might use nicotine. So, if you have 1 gram of nicotine dissolved in 100 milliliters of solution, what is the concentration of that solution? Go ahead real quick, try and work that out, and then come back and you can see me work that out. All right, so looking at nicotine. So I'm going to need the paper. I'm also going to need my periodic table. Okay, so carbon is 12.011. Nitrogen is 14.007. Hydrogen is 1.0079. And is there any oxygen in nicotine? I don't recall. There is not. It's just carbon, hydrogen, and nitrogen. All right, and there are 10 carbons, there are 2 nitrogens, and there are 14 hydrogens. So we add all that together. What is the molar mass of nicotine? Molar mass of nicotine is 162.235 grams per mole. We have 1 gram of it. We divide that by the molar mass. What is the number of moles of our nicotine? 1 divided by 162.235. 0.006163 moles of our nicotine. Now I said that is dissolved in 100 mils of our solution. That's what we're looking at right there. So we divide that by 0.10000 liters. Don't forget, when you're doing a calculation like this, you have to convert it to liters first. That's going to get us a concentration of 0.06164 molar. Now, I honestly don't know how much nicotine you get out of smoking a cigarette. That's not something I've ever looked up. I've never really been able to smoke cigarettes. Just never did anything for me. I guess I got lucky in that way, because some people really seem to like it. So, what if you dilute that by a factor of 100? So you take 1 mil of this, and you add 99 milliliters of water, and then shake the hell out of it. Because according to homeopathy, it's really important that you shake it when you do that dilution. So you dilute it 1 to 100, you're going to take the concentration down by a factor of 100. But just to spell that out, M1V1 equals M2V2. The initial concentration, the initial volume, the final volume, we know those. 0.06164, 1 mil, 100 mils, right? So our final volume, M1V1 over V2, 0.6164 molar times 1 mil divided by 100 mils. I'm not even going to bother with sig figs at this point because it's just so trivial. Oh, it's 0.06164. Well, the decimal place is just going to move 2 to the left. You're just dividing it by 100. 0.0006164. So you dilute that 100 times, you're going to go to 6.164 times 10 to the negative 5th. Nope, sorry, 6th, because this is times 10 to the negative 4th. You dilute that again, 6.164 times 10 to the negative 8th molar. The concentration just keeps going down and down and down. So we started at 6.164 times 10 to the negative 2nd, and then we went to 10 to the negative 4th for the first dilution, and then 10 to the negative 6th for the second dilution, and then negative 8th for the third dilution. So what if you diluted it a total of 20 times? Well, your final concentration would be 6.164 times 10 to the negative 22nd molar. This is a real thing that homeopathy practitioners do. You look at the side of a homeopathic medicine, and it'll have something like 200C written on it. 200C means that they do this not 20 times, but 200 times. Seriously, they might just do 10x, where they dilute it 1 to 10, that's what the x means, and they only do it 10 times. But they honestly do 200C dilutions because they think that the more dilute their medicine is, the more powerful it is. This is absolutely ridiculous. So we have a 6.164 times 10 to the negative 22nd molar solution. So what volume of solution would you need to have a single particle of nicotine? Well, remember, 1 mole is equal to 6.022 times 10 to the 23rd particles. You reverse that, then 1 particle is equal to 1 divided by 6.022 times 10 to the 23rd. One particle is a concentration of 1.661 times 10 to the negative 24th. Okay. So the reason I'm really pointing this out, or 1.611 times 10 to the negative 24th moles, the reason I'm pointing this out is because if you do a homeopathic dilution, you're getting down to the point where there might not even be a single particle, a single molecule of the so-called active ingredient left in their solution. If you did it 200 times, you absolutely wouldn't. You would need a volume of liquid, a volume of their solution, the size of the entire Earth, just to have a 50-50 chance of getting a single molecule of the so-called medicine. Okay. So this was partly an exercise in showing you serial dilutions, but also I really hate quack pseudoscience, quack medicines like medicines. And you have to watch out for this because they sell this shit at CVS. When you pick something up, check to see if it has homeopathic remedy written anywhere on it. Something that's really popular, has been for a really long time, is something called oscillofloxacin. This is sold as a flu remedy. It's a homeopathic medicine made from duck liver. You can actually see the homeopathy written in there. Oslo. Remember, like I said, they think the shaking it is what makes it magic. So this is one of the ways that I think, at least, chemistry can have a valuable impact on your everyday life, because now you understand why homeopathy is horse crap. It really is literally just magic, because there's virtually nothing left. Okay, real medicine, yeah, it comes in fairly small quantities, but we're talking milligrams, not almost nothing. All right. These things have a big effect the more there is, not the less there is. Homeopathy is garbage. All right. With that, we're done talking about dilutions. I'll see you in a minute or two to start talking about titrations. See you. Oh, no, sorry. Solution stoic. Ooh, titration comes after that. Solution stoic is going to come next. See you then.